Alrighty, so today we're going to go ahead and talk about complex numbers. Complex numbers are the set of all imaginary and real numbers together. A complex number is a number that can be written in the form a plus bi, where a and b are real numbers, including 0. The real part is a, the imaginary part is the I. And imaginary number I is a number whose square is -1, so that I squared is -1, and I is equal to the square root of -1. Alright, identifying complex numbers. So just like taking the square root of a normal number, I can now take the square root of a negative number because the negative part just turns into I. The square root of -4 is just 2i, because square root of 4 is 2. Square root of that negative is I. And then if I have that thin quantity squared, it's just -4. So let's do some of the stuff together. So the square root of -8. So the square root of that negative number turns into I. So then I have I square root 8. And I know that 8 can break down into 2 and 4. And my 4 breaks down into 2 and 2. So I have 2 buddies come out. So I have 2i root 2. Alright, the second one. 2 only breaks down into 2 and 1, and so that doesn't really work. So I can't break that down. But I can take the square root of that -1. So I have I square root of 2. So I've got I square root of 54. 54 breaks into 2 times 27. 27, ooh, okay, what are you doing? My computer's jumping on me. 27 breaks down into 3 and 9. 9 breaks down into 3 and 3. So I have 3 buddies come out. I still have that I there. And then inside the square root is my guys left over, which is 2 and 3, which will give me 6. So I have 3i square root of 6. Okay, so when I have numbers under my square root with regular parts, I'm going to simplify it down, and then I'm going to write the real number and then the imaginary number. So first, I have I square root of 18 plus 7. 18 gives me 9 and 2. 9 gives me 3 and 3. So I have 3i root 2. Because my 3's came outside, they came out to hang out with my I. 2's left underneath. Plus 7. Well, I want to rewrite that so the real part comes first. So 7 plus 3i root 2. This part will give me, well, the square root of 121, if you check your chart, that's 11. So the square root of that negative gives me I. So that minus 5. So let's rewrite it. So I have -5 plus 11i. So I'm trying to come up with numbers that go into my 289 here. So I'm trying to, I don't have my answer key on me today while I'm making this video. So 2 and 3 and 4, 5, 6, 7, 8, 11. Haha. Took me a little bit. But this will give me 17 and 17. So that one's a perfect one. For some reason, that number didn't jump out of my head. So I literally sat there dividing numbers until I got 17. So I have 17i plus 12, which if we rewrite is 12 plus 17i. Now when I take 108, let's try dividing it by 3 because I know we do 2. So 108 divided by 2 gives me 54. And then 54 gives me 3 and 18. And 18 gives me 2 and 9. And 9 gives me 3 and 3. So let's look for our buddies. So I have 3 come out, and I have this 2 come out. So I have 3 times 2, which is, 6. So I have 6i with a little 3 hanging out inside. Minus 29. Now I want to rewrite that so the real part is first. Real part meaning not with I. So that's negative 29 plus 6i root 3. Okay, so now you really need your calculator, so make sure you grab that handy dandy thing. What we're going to do next is find the absolute value. So what that's saying is that if I were to graph this out in a imaginary plane, which yes, unfortunately it sounds like it wouldn't exist, but it does. This is the distance from the origin or my center to wherever this point could be. So when I do that, whatever my A value is, I take that number, square it, and add it to my B number squared. So in this case, I only have one number. So I have the square root of 7 squared, which my square root and my square cancel each other out. So my answer here is just 7. The second one, I'm going to have 2 squared plus 5 squared. Now, yes, I see a negative here. However, it's going to be negative 2 quantity squared, which will give me the same thing as positive. So what I can do is, what I like to do is I just turn them all into positive numbers because then I can go ahead and just do the correct operations there. So I have negative 2 times negative 2, which is 4, plus 5 times 5, which is 25, which is just 29. And 29 doesn't break down. Same idea as one with 3. If there's a single term by itself, it's just going to be whatever that number is. So in this case, it's going to be 5. This one I have 2 numbers, so I'm going to have 6 squared plus 4 squared. So I get 36 plus 16, which gives me square root of 52, which we can do 2 and 26, which is 2 and 13, which is equal to 2 root 13. And then like here, just like 1 and 3, this one's only a single number. So it's just going to be whatever that number is. All right, that's all I have for you today. I'll see you tomorrow.